architecture. I know it's a very delicate and controversial topic, so please come here with open-minded and open heart, because it will be, I don't know, like interesting, I guess, or I hope so. So before we talk about architecture, let me show you this Pokemon app, and don't expect my app to be as cool as the previous speak about animation. I didn't do anything on UI. This is just a demo app that it's built on top of the Flutter template skeleton, and I use it for mainly talk about architecture. So first, I'll show you the app, which it happens when I click that button. So this app doesn't do much more than showing a list of Pokemon. So as you saw, as we enter the app, there is a fetch. It is actually working in real time now with the Pokemon OpenAPI, and it fetch one Pokemon. So I usually think about this app that I could have this app installed in 2 or 3 devices, and therefore, when I fetch, I always add a new Pokemon, because the other device could have just added or caught a new Pokemon. I think about this app as a Pokédex, so something that when I catch a Pokemon, I will add it here. And then I can remove a Pokemon, like you see. As I said, when I refresh, you always add a new Pokemon. So I can see, for instance, 3 Pokemons. And when I enter the Pokemon, then I can see the details. So all the information that they come from the server, I trim them down, and some of them are shown here on the UI. I also, let me show you how I handle the error as well. So now I have an artificial error. So whenever I try to add a Pokemon, because I think maybe I'm catching up now a Pokemon, and I want to communicate this, then the error is just shown a very simple snack bar that pops up. And I add these 3 buttons here to facilitate, because I'm using the simulator, so to facilitate my talk. But you can think about that you would just add, it could be a to-do app for the list, so you will add a new list or remove a list. Or architecture-wise, it could be a messaging app, so you're adding a new message or deleting a message. It could be an e-commerce. I think this architecture is flexible enough that it covers maybe most of the applications out there. So that given, now I will remove the error, and instead I will enable some artificial delay. So I added 3 seconds artificial delay on any operation that we have in this app, because I want to kind of see it a little bit slow down what's going to happen. So when I enter, as you saw, there was no Pokemon, then there is the 3 Pokemon that I had before, which are fetched by the local database, and then there is also the fetch to the server that he added the 4th Pokemon. Did you notice that? Okay. Then when I see the detail of a Pokemon, as you can see, before they were of course immediate, but now with the 3 seconds delay, we can see that there is the fetch from the database, and then they're shown on the UI. The same when I remove a Pokemon, it takes a little bit before the operation is done, and then the Pokemon get removed. Please note that while I remove a Pokemon, the application remains fully functional, so I can see the detail of another Pokemon. Let me show you again. If I see the detail of this, when I enter the detail again, as you notice, now they are not fetched anymore, so they're kept in memory, cached. This is a choice you can do. So now these 2 Pokemon, for instance, they always are in memory, the details, I mean. And what's going to happen if I remove the first, because it always removes the first, I can clearly use the rest of the app with no operation that interrupt my flow. So if this would be an e-commerce app, you could do anything you want, and meanwhile, the kind of background operation will continue. The same 3 operations that I have on the UI with the 3 buttons are also, I hide them in a kind of settings menu, because I want to symbolize here that they could be also kind of background operation. They could come not from the UI, but they could come via an SMS, for instance. They could come from Firebase. They could come with a push notification. And still your application should be working. So let's see what's going to happen. So here I have my Charmander, which is the only Pokemon in the list. Let's see what's going to happen if someone, which is me but not from the UI, delete it while I'm looking at it. Because of course you are doing maybe a very complex operation, you are filling a form and it takes time, but for whatever reason it's an auction or something like that, the auction is closed. So it's useless to let the user to still continue to fill the form when you know already that it's pointless. So you can still, your UI can still be reactive and communicate to the user that this operation now it's pointless for you to continue. Clear? Okay, I take it as a yes. So I made this presentation into 4 parts. So there is an intro, then there is a part about state management, because I can't talk about architecture if I don't touch state management. Then there is a core part which is about architecture, and last but not least there is an outro where I'm going to tell you which one is the best state management you can use. So how it started? We have Philip here, so I don't know if you recognize, he's the same guy in both the pictures. Philip was in the Flutter team, for someone that doesn't know, and now he's not in the Flutter team anymore, so I really consider him very precious because now he can give his personal opinion, which are very interesting. But nevertheless, how he started, so he was on stage in Google I/O in the summer, Google I/O 2018, on stage with Matt, and there they presented block, business logic of components. I assume everyone here is familiar with block. So it was presented there. There is the source in this presentation, so if you click, you can just watch the video. It's very interesting. I recommend to watch both the video if you don't know them already. And they introduced block, and the community was very, very happy because the Flutter community was already asking some reference to how to manage the state of an app, and block came in. But then, in 1 year later, in 2019, on the same stage, the same summer actually, 1 year later, in the summer, on the same stage, the same 2 guys, they kind of read the very same thing that they did in the first speech, but this time they show to us how to use provider. And it's extremely interesting to me because they also recommend not to use the provider package as released or published by Google, because Google had their own provider package. But they instead recommended to use a package created by this young, very talented French guy, Remy. I don't know if he's here, but definitely it's in this conference. Hi Remy, wherever you are. They recommended to use that package. And they explained. So I truly believe that in between these two videos or 2 speeches in 1 year, a big misunderstanding happened. And that's actually when I jumped into Flutter, or I started to look into Flutter. I was working in Nokia back then, and then I kind of couldn't figure it out what was the way to go until the second video came out in 2019, and I really liked what the guys showed there. And this is how it's going nowadays. We have provided Riverpod set state, inherited with jet, redux, block, get it, getx, triple pattern, and much, much, much more. There is the source from the official site. You can see there. If you don't like, there is my mate, Mike comparison, which compares all the packages that we have for state management solution. And he has also quite a nice metrics on what, like for kind of ranking the packages. I don't know if you're familiar with this chart, but there is the source here as well. As you can see, unfortunately, number 1 is getx. How many of you use getx? Security? Just joking, it's fine. So let's talk about state management briefly. So what is state management? Obviously, it's a way to manage the state. But let's define state a little bit. This is the best I could come up with, which is that
A state, it's all the info that you need to build or rebuild your UI, anything you need. And when I mean rebuild, I don't mean that you only build the UI for the first time, or you build the UI in the next step when you move from one state to the next state. But you rebuild the UI also when in between two user sessions. So like if the user log out and log in again, you want to recreate the same state that you had before. And this is what it's a state. It's very abstract, but I hope it's clear to everyone. It's like what you need to build the UI. There are, if you don't know, two kinds of states. One is ephemeral state, and one is application state. Ephemeral state, it's defined, it can be defined as, you can see the picture here, as the state that it's kind of all included into one widget, that it's nested into one widget. And for that kind of state, which is ephemeral state, set state and stateful widgets are totally fine. You don't need anything else. Set state is fine for ephemeral states. Examples of ephemeral states are, for instance, if you have a view pager and then you want to know which one is the current view. So the state that keeps track of the index of the current view. No other part of your application needs to know anything about that. It's only the view pager, and therefore this is an ephemeral state. Then there is application state, where you actually need state management techniques. And this happens in, I guess, two cases. One is when your state needs to be shared in between 2 or 3 or more views. So then you need to kind of move the state away from your view and put it into another class, which is usually called a state holder, because it holds the state. And or when you have only one view, but you still want, maybe the state gets so complex that you want to move it into another class to handle it better. And this allows you also to recreate the state in between user sessions. When I talk about views in this context, or widgets, they are the same things to me. So widgets, views, or pages, they're the very same thing. This applies to full screen pages, or it applies to part of a page, which is a widget that maybe it's complex enough to require an application state. Or maybe yes, part of the state that is shared in between 2 or 3 widgets. Then there is simple state management, which is what Philip and Matt showed in the second video that I mentioned before. It's also called pragmatic state management. It's the only one that is officially documented in Flutter.dev. I was a little bit lost when I started to look into all these state management packages, and therefore I went back to the only official source that it's for Flutter. I like things to come from official sources, not from some people that they do maybe things that can be against the system. I don't like that. So it's the only documented one. It's based on provider and ChangeNotifier. Here you see it's Riverpod and ChangeNotifier, because provider and Riverpod, they're the very same thing. If you don't know, Riverpod is the second take over provider by the same young and talented French guy, Remy, when he realized with the know-how how he could do things better. So Riverpod does the very same thing as provider in a better way. And better, it can be defined in this context for Riverpod as Remy thinks is smarter because Riverpod, everything's global and it doesn't touch the widget tree. But for this presentation, you can use provider, you can use Riverpod, but if you are starting an app or if you have an app that is using provider, go for Riverpod instead. It's very easy to migrate, and Riverpod is the future. So there is no ambiguity there. How this works, this simple state management, I like it because it's simple. My brain is very dummy, so I need things to be super simple. So it works with 3 elements. There are the change notifiers that are the state holders. So what they do, they hold the state, and then they need to notify about a state change. And that's the only things they do. They notify. They have a method called notify listeners that every time you call it, the change notifiers, they give you full control. So you are the one that have to call it. You call it, and then it notifies that something has changed. Then the UI needs to have a handler over the change notifier. Therefore, Riverpod is the tool that provides the change notifier classes to the UI so that the UI can interact with them. And last but not least, the UI needs to consume the changes of the state. And this happens with some classes that are called consumers. There is a consumer widget that you can use straight ahead, and then there are two classes that they replace the stateful and stateless widgets for Riverpod, and they basically consume the UI. Now, what is Riverpod? For me, it was very difficult to define what it was. Therefore, I had to use the one-liner from Remy. Remy, whatever it does, it's very thick. So we need to bisect it word by word. It's not easy to understand. So Riverpod, while Block and other are state management solutions, Riverpod's scope is a little bit broader. It does a little bit more. And it's a framework, and it's a reactive framework. What does it mean? It means that it's not imperative. You don't go and do actions. You just stay there and wait for something to happen and be notified about. There is reactiveness in it. And it does data binding. So your UI, it's always synchronized with your data. And it does caching. So your data can be kept in memory as cached for you by Riverpod. So reactive caching and data binding framework. That's why I think if you're still using provider, go for Riverpod, because Riverpod scope, it's broader, and it does more than provider. So now let's define what we mean with architecture. Architecture, as you see, it comes from Greek. This is the best definition I was able to come up with, at least from my point of view. It comes from architect, which is from Greek, and it means chief builder. So people are building something like a house or even something bigger, like, I don't know, a temple, a Greek temple, and you need someone to coordinate. You need someone to tell to the builders which material to use, how to use it, what it is its purpose, and someone that design the temple, that design which parts are and what do they do and what is their purpose. So this is what we mean with architect, even for code. So it's the structure, and it's the design of a system. This is very general, very abstract, but it works. So we go into example of what we mean for an application, but this is in the very general level. Why would you need an architecture? Is there anyone here who doesn't use an architecture? Okay, good. So I guess you understand the reasoning behind it. So mobile applications are different from, for instance, monolithic desktop applications. So mobile applications, they're made out of parts, or as Android think about them, components, which can be torn down by the system at any time independently from each other. And you need your app to still work if one of them go down, and then it's started up again. And the architecture is what it helps you to achieve that. It's based on 4 principles, or if you use it, you will find 4 principles. And you want to use it because then your code is more maintainable, it's more robust, it can be better tested, and it's scalable. So I guess these are clear for all of one here, but like maintainable, it means you can refactor the code or change the code very easily. Robust, that you don't have much bugs, especially in production. Scalable, if new features are added, it shouldn't matter much if there are 2 more features or 20 more features. The code should scale, and testable, because when you isolate part of the app, then it's easier to test. And then there is some principles that when you basically have an architecture, then you will see them. They come out of the code, and you can find them in the code. So one is the separation of concern, which means that you want to make sure that a class doesn't do 2 things. You want to make sure that each class does one thing and one thing only, and it's well done. So the concern, the responsibilities for each class are separated. Then you want to drive your UI from your data models, and possibly to persist the data models. You want to have, for each data type, a single source of truth, and you want to be very clear where it's the single source of truth, who's responsible for it, who owns it. And then we will see we have also unidirectional data flow, which means that your data must go from the UI all the way down to the bottom layer of your app, and then come back to the UI in one way. As we said, architecture, it's also structure. So first thing you want to do, you want to structure your code. I recommend you to use feature folders, but there are alternatives. Anything works as well as long as it's well documented. So in this case, for instance, I built this Pokemon demo on top of the template. So there is the settings and the localization were part of the template, and then there is the Pokemon feature I added. I added also a network layer and a core. Rule of thumb, it's simple. Like if you want to remove a feature, it should be as simple as you remove one folder. If your app doesn't do that, you need to refactor that immediately. Yes, the template. So I may be wrong, but when I looked into the template, I liked it a lot because the template, I don't know if you're familiar with it, it was introduced with Android 2.5, the new template or skeleton template, and it's the one that there is the dark theme and light theme, and it's basically kept in memory. And they use a setting controller, which is implemented with a ChangeNotifier. And that's basically what show me that they hint, what they hint, it's an MVC, model view controller. I hope everyone of you heard about this. This is the most general architecture you can think of. And it's nice because it's general enough that you can use it in many different cases. So it's made of 3 layers. Oh, one thing I forgot. Sorry, I have to go back a second. Not only I looked into the template, but because I was a little bit lost in 2018 when I started to look into architecture, and then 2019. So I'm an Android developer. I have an Android developer background. So the only thing that I really needed was a reference, because there are so many packages that they tell you, you just do this, but they don't explain you why would you actually do what you're supposed to do. So I used Android architecture component as a reference for this architecture. And it became very nice later on, because these pictures are basically taken from Android architecture component. Now they're rewriting all of it, as I could see in the last months, because now they have compose. So now that they have composed, Android architecture is getting even more similar to what we use already in Flutter, because now they're also composing the UI. So for me, it was a real match. So it was easy to use all the ideas from Android architecture component that they still work for Flutter, and they should work for us as well. So we have 3 layers. There is the UI layers, the domain layer, and the data layer. The views and the controllers, they are in the UI layer. The domain layer, it's optional, and it's mainly use cases. And then there is the data layer that are repositories and data sources. Domain layer is optional, so I'm not going to touch it for this presentation, but I'm going to have one slide a little bit later on. So the views. The views, they want to do, of course, everyone, I hope it's clear to everyone what we mean here with views. So they are stateful or stateless widgets. We saw before that the stateless are for the ephemeral state, and the stateful are, the opposite. The stateful are for the ephemeral state, and the stateless are for the application state. Because the moment that you take your state away from a stateful widget, you can use a stateless one instead. Your state, it's somewhere else. It's in the controller. The purpose of the views is mainly 2 purposes. One, you want to display the data on the screen. So whatever it's in your data layer, you want to represent it on the screen. And then you want to capture the user interaction when the user click the UI. And so we can say that it's a visual representation of the app state from the data layer directly. And last but not least, when we have this build method, we want to build as fast as possible. We don't want to do any type of logic there. If you see any type of parsing, any type of, changing the text, any type of calculation, you're doing it wrong. Take anything away from your build method. Your build method must just execute as fast as it can. No logic. And we need to rethink the way we see the views, at least if you come from this imperative way like Android is. So instead of having, a view text, a text view, and to set the text of the view, which is imperative, we need to instead think in a declarative way. So we declare the state somewhere else. When the state update, the UI will rebuild. Nothing to say to the UI. I use this metaphor of the movies because we all know that the movies, when we go and watch a movie, the movie, it's a fluid experience, obviously, but we know that it's 24 frames per second. So they're just pictures instead. They're just pictures shot to us very, very, very fast. And we need to have the same way that we think the UI. The UI is just a series of pictures. Even when there is an animation, the animation is very fluid. It's just a series of pictures built one after each other. So the good model for this, it's a finite state machine. I assume everyone here knows what is a finite state machine. And there is the very famous function that the UI is a function of the state. So for instance, in my demo app, I have a state 0, which is when I enter the app, before I do anything, I just see that there is no Pokemon. You have no Pokemon, I'm very sorry for you. This is my state 0. Then one Pokemon come in at one point, either I catch it or I refresh. And this is my state 1. Then 2 Pokemon come in. This is my state 2. And this goes on and on and on. It's almost an infinite list. There are 1,141 Pokemon in the Open API at the moment. So it's quite a long list. Okay, so either finite state machine or infinite state machine, it doesn't make much of a difference. But then there is also the loading, which is, of course, not the same state. So I can go from my state 0 to my state 0 loading. And from my state 0 loading, I can go to the state 1 very easily. Nothing, something is happening, and then there is one Pokemon. And the states for the loading, they're all equivalent. So for each one of the states, I have also the loading. And then last but not least, I have also the error. For each one of them, the error, it's another state. It's not something that comes on top of it. It's a separate state. When you draw the UI, you draw an empty list with an error. And this is, again, a kind of infinite list. So I have all these states, and I can move from one to the next according to the rules of a finite state machine. Clear? Good. So UIState, as you saw, the UI has the loading, he has the error, and he has the Pokemon list. So you want a class, which I called Pokemon UIState, which contains all of them. And it's very important that this class is immutable, because you want to manipulate this class to move from one state to the next in an immutable way. So you will have a copy method that it will just change only one of the elements of your UI, of your state or UI state, without changing the other ones at the same time. And so it's immutable, and it's a very simple class. And then there is when there is the list, it's not a list of Pokemon, but it's a list of Pokemon item UI state, which is this other simple class, because when I fetch a Pokemon, there is a lot of information there, but in the initial page, not in the detail page, but in the initial page, I don't show all the information. So there is no point to bring there all that information. You need to trim down your classes to only what is needed by the UI. And this is, if you implement, and if you think your UI this way, it's very nice, because when you have a combined feature, like, I don't know, maybe if I am registered in this application and if I am a premium user, I could like the Pokemon. There could be, I have this feature that I can like them. Then you would have this information here as a combined information based on the two items that you have in this class. Then there are the controllers. The controllers, they are, we saw before that they hold the UI state. So that's one of their responsibility. And then they also handle the user interaction. So when someone clicks the UI, and then this information is given to the controller knows what to do with that. And they return back to the UI the state for consumption. And then they are the one also that they manipulate, so they change the data model. Controllers are the one responsible for changing your data set. So for instance, this is how the Pokemon controller is implemented. It's a change notifier, as you can see. He owns the state, so he has a reference of the state. And he has all the operation that I can do on the UI, so I can create, delete, and refresh. And then there is, of course, one dispose. And it's listening to the changes of the dataset through the repositories watch all. Then there are the repositories. What they are like classes where your data is stored, and they actually are very important because what they do, they are the one that they orchestrate for each data type in between the data sources. So you will have more than one data source, or even zero if you want, and they will orchestrate, so they will be the one deciding where you get your data first. Like, do you want to have an offline first approach? Do you want to have an always online approach? These are the classes where you do this type of choices, and the one that you give responsibility for this type of choices. They have CRUD operations, which are one shot, so you can create, read, update, and delete your data set. And then when your data change, you need to have some operation for that as well. So if you look at the class, for instance, there are all of them, all the CRUD operation, and then I expose two methods which are stream, because you want to have the reactiveness in your application. But I use stream here because I guess that's what most of you are familiar with. But I personally prefer to use value notifier here. But that's a matter of choice. The important is that whenever the repository changes the data, this can be brought back to whoever is listening. And the repositories, they expose the immutable data, trim down. So if the Pokemon before the repository, he has a huge list of fields. After the repository, he exposes only what the UI needs, nothing else. And they know, the repositories, which one is your single source of truth, which is per repo. So different repositories. So if I have a movies repository and a songs repository, they can have different single source of truth, and it's well defined there. And they contain business logic. Then data sources are very, I guess, easy classes. So they basically can be database or network. Usually, by default, a repository always will have a local data source and a remote data source, at least. And then they expose the one-shot CRUD operations, like the repositories. And then it's important that no one else in your application access the data sources but your repositories. So all the communication that manipulate your data, you go through the repositories. Now let's see how this works throughout all our architecture. So first of all, when I click to refresh the Pokemon, so as you can see, there is a floating action button that basically needs to have access to the Pokemon controller to tell it that we want to refresh your Pokemon data. And this happens through provider, so through Riverpod. So there is because my controller is a change notifier, there is this class called change notifier provider that will give or will expose the change notifier, which is my controller, to the UI. And the UI needs only to have this ref and then be able to read it, because these are UI actions. So you don't want to rebuild your UI. You want only to have this read action. So you don't rebuild the UI, but you just click and then do an action like refresh or add a Pokemon or remove a Pokemon and so forth. So I hope this is pretty simple and straightforward. You have a controller provider which is global, and then you can access it because it's global. You can access it anywhere in your UI and just read it and trigger the action. And this is how the first part of the communication goes. When the controller does something, okay, we want to refresh the data set, so the Pokemon, then it does that, and at one point the controller is notified that, okay, now the data set is refreshed, here it is. The controllers, they need to communicate this back to the views, to the UI. And this is how they do it. So on the controller, as you can see, when we receive a new data set, a new list of Pokemon, we update the state, which is just a copy because the state is immutable, and then we just notify the listener, nothing else. We update the state, I move from state 3 to state 4, just rebuild yourself. On the UI side, here it's on my Pokemon page. This time I watch to the provider because I want to rebuild my widget, which is a consumer widget, so it consumes the UI. And I don't want, because if you remember, my state is full inclusive. It has the loading, it has the error, and it has the list. I don't want to, this is only for my Pokemon list widget. I don't want to rebuild this part of the UI every time, for instance, the app is loading or it stops loading, because the list didn't change in that case. So I have the select. So this is something that Riverpod allow me to do, so I can just listen to the state of my controller, and in between all the elements of the state, I can only listen to the changes in the Pokemon list. When the list change, this UI will rebuild. So if something else in the state change, this UI doesn't rebuild. Then let's see how the controllers communicate to the data model. So when we say that you need to refresh the Pokemon list, also the controller need to forward this information to the repositories. And this is as simple as the method that the controller said that now I'm loading, and now refresh the repository, refresh the data set, and we catch the exception. So if there are some errors, we catch them here. And if you see, this is the same code that I showed before, but this time I also show that we pass the repository to the controller when the provider is created. He creates the Pokemon controller and he passes the repository. This is dependency injection. I know Remy doesn't like to use Riverpod or to be promoted as being able to do dependency injection, but it can do that as well. So you just read through the ref, you just read from the Pokemon repository provider, and this will provide you the repository. So you just, it's the very same as we get it, you could do it from the registry and you get the repository from there. And last but not least, the repository does whatever it does when it needs to refresh the state, and then it gives the information back to the controller. So the controller needs to actually watch all the changes in the repository, and then, as we saw before, it notify the listener. I think this is fairly easy. Unidirectional data flow. So I click, I want to refresh the Pokemon. This information from the view is given to the controller, and the controller tells to the repositories that we want to change this data set. The repository does the change, and then through the data sources, then it persists it. And only when it's persisted, then the operation is concluded and it's positive, and then it's given back with a new data set that's returned to the controller, and from the controller notify the view that now there is a new data set, please rebuild yourself. This is called unidirectional data flow because it goes all the way, the user events, they go all the way from the UI layer to the data layer, and then from the data layer, they bounce back to the UI layer, the data. The only part that I skipped, which was optional, is the domain layer. And here you want to have, you want to do two things here. You want to reuse business logic. So if you are, for instance, if you have a data formatter and you want to format your date in some way, you will have a format the date use case here. Or if you want to do something a little bit more complex, like if you have a bank transaction and then you have the parties, but your transaction repository doesn't actually list the names of the parties, it just lists the IDs, and you want to map the IDs to names, for instance, you would need some classes that they can handle both the repositories. They are like repository managers. So this is very good because when you start to use cases, you extract all these simple functions into one place, then you can modify them even later on very easily and without extra changes. So to conclude, I hope I'm in time, yes. There are many different architectures. Some of them are better than the others, but we need to define what do we mean with better, and we need to understand based on which metrics do we define better architectures. For me, it was simplicity. I like things to be very simple, so I think that this approach with Riverpod and ChangeNotifier, it's extremely simple, and it's easy to follow, and it works beautifully. And unfortunately, which one is the best state management package? It depends. It depends a lot. So what I saw and what I see is that architecture is never talked in the team or in the company, or rarely talked. What I see is that when you enter a team, then you're like, why do we use this architecture? If you ask that question, sometimes you don't even get answers. And what I see sometimes is that not all the team is on the same page on why this architecture was chosen and based on which metrics and based on which reasoning and all of that. So I honestly think that code is a reflection of my mental model and your mental model, and it must be a reflection of your mental model. You need to understand the code that you work against every day, and you need to that this code match your mental model. If it doesn't, then you will have difficulties to work with this code. So I recommend everyone to have clear why you're using the architecture you're using, and maybe to try even 2 or 3 different architecture and see what works best for you. There isn't one that is best for everyone, but what I presented here today, it's simple, it's scalable, and it works very nicely. Thank you.
Thank you very much. That was a great talk. We have a couple minutes just for a few questions.